Good evening, everyone, and thank you for joining our second session for this week, part 2 of Understanding HDMI 2.1. This is Frederick from Sound United, and I'm joining you all this evening from Hong Kong. Alankara, who is my colleague Alan, and I would like to thank our partners across South Asia, India, Pakistan, the Arab Emirates, and the Gulf states. And we would like to personally thank all the participants from the Gulf states and the Arab Emirates for attending during their Ramadan. So welcome everyone. Joining us tonight as well are my colleagues Jim from Minnesota and Jen in San Francisco, San Diego, California. And our host tonight again is Phil, joining us from his lovely home in San Diego, where it is currently 8 a.m. in the morning. Over to you, Phil.
Good morning, everyone. As he said, welcome to my lovely home. I am Phil, and we're going to talk more about HDMI 2.1. And we already did a session yesterday about 2.1, and we talked about cables and bandwidth and things like that. So now we're going to talk about things that go beyond resolution and frame rate, because that is what you hear all of the time. So we want to let people know that there's more to it. And for many customers, those other things are going to be the things that they really gravitate to when we're talking about HDMI 2.1. Okay, so let's get started here. So my name is Phil Jones. As he said, I am the Director of Training for Sound United, all the different products all the different brands, Denon and Marantz Class A Definitive, Boston Acoustics, and Polk Audio. To get the full impact of what we've been talking about, please watch there's another session that we did yesterday that went pretty long, 90 minutes. You don't have to watch the whole thing unless you want all the Q&A. That will cover some of the other technical things we're not going to cover today. So hopefully between the first session and the second session, you will have a very good foundation when it comes to HDMI 2.1. So we talked yesterday that they introduced a new spec to give you better video, better audio, and an enhanced gaming experience, and also a better user experience. And it's the video enhancements that really increased the bandwidth that really made it a requirement to make a new HDMI standard. And we also talked yesterday about the fact that there's 5 elements to video: resolution, how many frames you're using, how much detail is in the color, what type of brightness scale am I using, and what color space am I using. And 2.1 actually increases 2 of them: resolution and frame rate. These are going from 4K to 8K, and going from 24p and 30p and 60p all the way up to 120 frames per second. So by increasing the frames, more frames means more. If I go from 24 photographs in a second to 120 photographs in a second, my earplug keeps coming out. The file size is going to get bigger. If I go from 8.8 megapixels to 32 megapixels of per frame, the photos are bigger, so the file size is bigger. This is why, if you look at that is why you need so much more data, the 48 gigahertz or 48 gigabits per second that we have been talking about yesterday. So TV manufacturers have really went out there and promoted this. So if you went out to CEDIA or CES, there were 8K TVs everywhere. And because this is a new thing for them to talk about, if 4K was great, well, 8K must even be better. So it's driving me crazy. So of course there's a lot of promotion for this, as well as high frame rate for those hardcore gamers out there that are looking for the best gaming experience. Now, we got asked a little bit about Ks, and I want to kind of go through and talk about the benefits of 8K or the benefits of more resolution before we move on and talk about why many customers may not be as interested in having additional resolution over 4K, but why they would still want to buy a 2.1 enabled device. So the first thing, what is a K? A few years ago, when I started off, 20 years ago, I'm an old guy wearing gray hair, gray beard. I started off selling VCRs, and that was 720p, actually 480 VCRs with 300, which basically is 395,000 pixels that made up the picture. Then we went to HD. And as we went to this HD, the size of the TVs got bigger. Anybody that's done this for a while, like me, if you've done this for a while, you remember that a large TV in a home was about 27 inches in the days of the VCR. And 32, people would say, why do you have such a big TV in your house? Then we went to HD, and you started to see these bigger 55-inch rear projection TVs. And if you got, and the people were like, wow, 32 became kind of the normal size. And then if you had a big TV, it was a 55-inch. But I still sat in the same location. It's just that I can have a bigger TV and it looked good. So why not get a bigger television set? And people say, what is a K? A K is 1024 in broadcast standard. So 1K video is a 1024. The width of the screen uses 1024 pixels. So professional video shoot in 2K. And then what they do is, instead of using all of that for HD TV, they basically lop off some of the side. So the K means 1024. That's why we call it 4K Ultra HD or Ultra HD TV. Because if I really call it 4K, it really doesn't mean, it isn't really the aspect ratio and the resolution we're talking about. So UHD, the TVs that are in your home, are 3840 by 2160, about 8.3 million pixels. Now 4K photography or 4K video in a cinema is actually 4096 by 2160. 4 times 1024 4Ks is where this comes from. So when they shoot in 4K, they basically lop off a little bit to make it fit in your screen. So if I didn't lop it off, you would have little black bars on the top and the bottom. So they say most people aren't going to miss 7% of the video when it comes to width. So we're just going to cut it off. So the cinema camera photography fits on a standard consumer television. And the reason why they decided to stick with this standard aspect ratio for UHD was because it's basically four HD TVs. Basically, I can have 4 HD TV, the resolution of 4 HD TVs in one location. I was actually at a TV manufacturer when this happened, and basically all they did was take the original sets. They took 4 42-inch HD TVs, and instead of cutting the glass into 4 TVs, they just made one big 84-inch. Ooh. So it wasn't like magic. They just basically, there was enough pixel density to make, from those smaller HD TVs, to make a large 4K TV. So in order to do that, they had to keep the aspect ratios the same, 16 by 9, 16 by 9. It also helps with the scaling, because all they have to do is double the pixels horizontally and vertically, actually horizontally and vertically, to make an HD image look right on a 4K TV. The mathematics are actually easier. So how close can you sit to these big TVs? Well, the best way to measure how close you can sit is based on picture heights. You would measure the height of the video that you're looking of your TV. So if you have a 75-inch TV, that's diagonally. You would actually measure the height from top to bottom. On an HD TV, the recommendation has always been 3 picture heights. So if you measure the top to the bottom of your TV, 3 times that distance is where the normal human cannot see the pixels that make up the image. When you increase the resolution, you cut that distance down. So for example, if I on a 4K TV, the distance is 1.5 picture heights. Now, if I sit 1.5 picture heights from a HD TV, I would see the screen door effect. I could literally see the pixels that make up the image. But on a 4K TV, I cannot. So the benefit to a consumer is you can sit closer to a bigger TV and the image will be clear. So before, you would be at 3 picture heights, and with 4K, you would be at 1.5 picture heights. The benefits of having more resolution. Now, eventually you feel like maybe am I really going to sit that close to a TV? And sometimes you do. This is actually a screen capture from um, my 4K TV. I use a 48-inch 4K TV for my computer monitor, and I sit about maybe 2 feet away from it. And as you can see, there's no way you can actually read the text on this slide, but it is crystal clear. So instead of me having 2 or 3 computer monitors on my desk, that would be like a 24-inch life-size like Apple monitor. I just have one big TV. It makes me a lot more productive. So there are some times where being able to sit closer is an absolute benefit. But if you go to 1.5 picture heights for 4K, 8K means you can sit less than 0.75 picture heights, 3/4 of a picture height. That is when it starts getting outrageous. So, for example, say I had a 120-inch screen. A 120-inch screen, like my theater screen, if I measure from top to bottom, is about 60 inches. What would that be, Frederick? Less than about a little bit more than a little, what, 2 meter, less than 2 meters? No, yeah, less than 2 meters. Um, and basically what would end up happening is for me to see the pixels on there, I could sit as close as 44 inches, less than 4 feet away. So think about how close that is. So take a super large projection screen and you can sit less than 4 feet from it. You'd be so close that you couldn't make out all of the details in the image. It would completely fill your field of vision and you could not see anything. To put that in perspective, in order to show 8K, when I was at my other job, we were launching a new 4K, 8K, 60p camera to shoot the content. So in order to show the full resolution, they built a 32-foot wide by 18-foot 8K crystal LED display. That's a big LED, micro LED display, like the Samsung wall, except for bigger, 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 bigger. And that display, since it was 18 feet high, you could stand closer than 13 feet to this. So imagine walking into the largest, an IMAX theater, and sitting in front of the very front row of an IMAX theater. It would be too close. But you know what? Sometimes uh, this display would be great if I was using it for, I don't know, fine details or an education where I wanted to have people walk up close and look at a heart or something like that. But a lot of times the resolution of 8K is kind of overkill. If you have a 65 or 75-inch 8K TV, you can literally sit um, a foot and a half away from an 84-inch 8K TV. Could you do it? Cool. But would you do it? Probably not. So 8K is cool on paper. Some people will want it. It'll really be great for things like for projection. I have a projection screen and I have a 120 and I sit about 12 feet away. I could put a 200 in my room now or 300 in my room if I wanted to, if it would fit. And a picture would be outstanding. But a lot of times people look at it and say, you know what, the resolution of 4K is enough. So do I really even need this 2.1 stuff? Any questions so far?
Distance recommended with multiplication of the picture height holds good with the resolution of the display.
Mhm.
Excuse me. Sitting closer to a 4 or 8K TV might help in the picture. What about surround sound? Obviously, not recommended.
Not recommended. One of the biggest problems Jim will tell you that we have when we do surround sound presentations is let me take that back off, is sometimes the screen gets so big we can't get the speakers in their optimum position. Remember, Jim, we actually at CEDIA this year, at CES this year, we limited ourselves to an 85-inch TV so we can keep the speakers about 6 feet apart, which was optimum. When you start putting these, we could have put in a gigantic screen, but the speakers would have been too close to the wall, and the distance apart would not have been as good for stereo reproduction. That is the reason why a center channel exists. So If I was for home theater, throw in a monstrous 200-inch screen and use the center channel to focus the image. But if you're doing just stereo playback, a lot of times those massive screens make the speakers so far apart, it could actually affect audio. And so Jim said, nothing bigger than an 85-inch TV. This is an audio demo, not a video demo. And I had to say, okay, Jim, no problem. So what was the next one, Jim?
What are the limitations of horizontal viewing angles as you begin to sit closer to a large 4K, 8K screen? Will that not negate the benefit of higher resolution since you would not be able to sit closer anyway? So if it's more than just you, what happens as you get off axis?
Well, that's a if you that's actually really good. That's some serious mathematics there. So basically, the closer I get, and I'm say I'm sitting directly in front of it like this, my angle is very good. But as I get as I have to, but the guy that has to sit next to me, that's sitting close, the closer you get, the more harsh that angle is of approach to the TV, and that could affect your color. OLEDs have very good even color at a very wide dispersion, very wide dispersion. LCDs are getting better as well. But the fact is, but no one I know sits 1.5 picture heights away from a 4K display, except for gamers. Gamers sit that close to those big old monitors. Can you imagine, like, if I play a little bit of gaming on my computer monitor in the office, and having a 48-inch TV 2 feet away for gaming, it fills my field of vision perfectly. It's not so wide that I can't see everything to the left and the right, but everything is a little bigger and a little sharper, and it gives me an advantage. So gamers may want to sit really close to a 4K, to a massive TV, but I guarantee you, most of you and most of your spouses are not going to want to sit 2 or 3 feet from a 100-inch television set. It just will not be comfortable. So, and by the time you get there, you wouldn't want to. By the time you get there, where the angle would affect the picture quality, you wouldn't want to sit there anyway.
THX recommends viewing angles of 36 degrees for larger screens across the width of the screen
Yes.
and the eye. What is your take on it, irrespective of pixel density?
Okay. There is a I think what they're talking about, I think he's talking about this type of viewing angle. So what the goal is to fill your field of vision. One of the reasons why I liked 4K TV is you want to, the more you fill you fill of your field of vision, the more engaging the content is. My kids really don't watch my big TV because if I hold a tablet this close, 2 feet from my head, it fills more of my field of vision than if you sit on my couch 14 feet away looking at my 75-inch TV. So the kids look at it and say, wow, this tablet this close, it fills my field of vision more than that 75-inch TV. So I'm just going to watch Netflix on this. So yes, so THX said to get that impact, you want that at 36. Me, I say 36 is good. You get too far, too wide, you can't see all of the action. Sometimes they use it for IMAX to make it more immersive, but many a times 36 is good. I just say look at a TV, stand back at a TV or display, ask yourself or ask the customer, how close, when does this not, when do I get to too close and this becomes uncomfortable? So if you have a showroom or you have a display, have the customer walk closer and closer and closer until the field of vision becomes uncomfortable for them. And that will tell you their angle. And then you determine based on their personal angle, how big of a set they need for where, or projector they need for where they're sitting. That's the best way to do it. But 36 is kind of a good reference. Okay. So let's continue on. So gaming systems are going to be the first things out there. And we just talked about the 8K is great, but 4K is enough for gaming when it comes to resolution, even if you're sitting close. So the higher frame rates, which gives you better motion clarity, are the things that they are most excited about. I see you quicker. You're running. You're crisper and easier for me to target. or it's easy for me to steal the soccer ball from you because the ball looks crisper. So they're more concerned with the higher frame rates than they have ever been when it comes to 8K. Now, we just talked about all this stuff. Oh my gosh. So you're telling me, Phil, that there's no reason to buy a 2.1 or an 8K or 4K high frame rate television? No, I'm not. I'm not telling you that. I'm telling you that the resolution may not be the main reason why many people are going to want the features available in 2.1. There's lots of other features that will increase the performance, your daily user experience, even if you stick with a 4K TV. So let's go in and talk about what those are. There's features that enhance gaming, and those features include things such as variable refresh rate, which we'll talk about, quick frame transport, and auto low latency mode. So I'm going to cover each one of these right now. And as Jim mentioned, this handout will be given to you, so you can actually go through here, so you don't have to take notes. And so I'm not going to read all of the text in the slide as a reference for you if I'm not talking to you. So the first thing, variable refresh rate. What does this do? Well, what ends up happening is a computer, depending on, or a game system, its GPU can only build images at so fast, and that speed that they can render a picture or a frame of video game, a picture frame that makes up the video game can be faster or slower depending on how much resolution, how much detail is in the content, and how powerful the computer is. So say the refresh rate on your TV is you're running at 60 hertz per 60 frames per second. And if I'm doing a very simple frame, it's easy for the computer to render it. Me standing by myself next to the ocean. Computer has no problems rendering those at 60 frames per second. The problem is when there's a lot of detail and the computer is trying to render this stuff as quickly as possible, and then the TV says, next frame, next frame, next frame. And what you end up with is basically tearing or lag. So what you end up with here is that TV does not have the ability to finish the frame it's working on before it has to start on the next frame. And so what you end up with, I wish this picture was closer, is if you look at the tear point right here, I need to make it bigger. It's like it was writing it, and then all of a sudden the picture jumped a few. If you look at this tree over here, that tree should be connected because it was writing one frame and then it had to immediately move to another frame, and you end up with tearing. Half the image is tore. If you look at the road below, you can also see it there, how the road is not perfectly straight. It is teared because the TV wants to move on before the computer is ready. What variable refresh rate does is the TV and the computer communicate, and based on the frame that is being made, the TV waits until the computer is done. If the computer can render a lot of frames quickly, the TV's frame rate will increase. If it requires more detail, or the person is stationary, the computer will spend more time building that frame and then hand it over to the TV, and the TV will wait. So what happens is you end up with every frame is optimized that from the computer to the TV, and all of the things like tearing and stuff is gone. And it helps reduce lag. If the second the frame is done, it sends it to the TV, and it also helps reduce lag. So you get less tearing, less stutter, and less lag. So it's a gaming thing. The cool thing is if you hit the menu structure on upcoming AVRs, it will tell you that it is actually running in variable refresh rate. So you can actually see in the little menu information thing, it'll tell you what the color space is, what the bit depth is, and if it's an HDR, and if it is running in variable refresh rate. A lot of times you have to turn this on. You're going to have to turn this on in the TV as well as in the receiver. and the game system has to have this on as well. Oh, by the way, this is universal. 2.1 made this a part of their certification or part of their standards, but this has been available for a while. If you have a NVIDIA card, it's called G-Sync, and if you have an AMD graphics card, it's called FreeSync. It's pretty much the same thing, except for G-Sync and FreeSync and HDMI VRR are not compatible with each other. G-Sync is its own proprietary technology. FreeSync is its own proprietary technology, and VRR is their own proprietary technology. The whole goal of variable refresh rate is to kind of standardize things. So any questions about that, Jim?
What will be the recommendation for distance on a 120-inch full HD projector?
The recommendation for distance for a HD projector, full HD projector, is 3 picture heights, period. So if the screen is 5 feet tall, you have to sit 15 feet away. If it's a 4K TV and the screen is 5 feet tall, you have to sit 1.5 picture heights away, which is a minimum of 7.5 feet. It's all based on picture heights. 3 picture heights for regardless of the aspect ratio for an HD screen, and 1.5 picture heights regardless of the aspect ratio, regardless of the display device for a 4K TV is the minimum. I'm not saying the comfortable, but the minimum viewing distance.
Okay. So the distance from the screen, if it's 3 times picture height, 2K is fine.
Yeah.
Yep.
Yes, exactly. Because you're to the point. So Jim and I were talking about this yesterday. If eventually you get to the point where and that's based on visual acuity of a human eye having 20/20 vision. If I write something in really tiny text, like what's on this slide right here, and you're sitting 75 feet away from a 50-inch TV, you can't read it. Eventually you get to the point where the human eye cannot discern details smaller than that, smaller than a certain point, and that point is where that picture height idea comes from.
So at some point, can you address HDMI 2.1 with 3D and how that
Not part of
affects
the
it?
standard. Not part of the standard. Just like
Not part of the
4K,
standard.
just like 4K HDR, 3D is really not part of the standard. Does not mean you can't do it or they're not going to do it, but there's really no part of the specification that even talks about 3D.
The next question is, if movies are recorded at 24 frames, does it help to set the display at 60 hertz to watch movies?
No. Set it better, because what you end up doing is the TV a lot of TVs will artificially build frames to fill in the gaps. And when it does that, you get the soap opera effect, and you get and a lot of times the TV's ability to build frames. There's a frame here and there's a frame here. So the TV will build a frame right in the middle. That frame in the middle is probably not going to be as good as the originals. Very good TVs are good at it, but most TVs are not. Your motion will be smoother, but it'll look like a soap opera, and you'll probably end up with distortion. If you have most 60 hertz TVs or TVs that refresh at 60 frames per second have they will try to do what's called 3-2 pull down, and to do that, the better TVs are 120 hertz, have 120 hertz refresh rate, because all it does is show each frame of a 24p signal 5 times. 5 times 24 equals 120. So a lot of higher end TVs have a cinema mode, and all it does is show 24p content, that frame, 5 times to match the refresh rate of the TV. That is going to look a lot more cinematic. Oh, and by the way, between the frames, they may actually even blink the image, or flicker the television set. That actually helps your vision. If I flicker the TV, it actually smooths the motion. It erases what you saw before. So cinemas do that naturally. Film flickers. So by flickering or blinking the backlight or inserting black frames, I can actually give you the same effect, and it looks more cinematic. So do not take 24 and add extra frames to make it 60. It's just not going to look cinematic. It's fine for sports. Taking 30p and making it 60p, it just makes the soccer ball smoother as it goes across, but it doesn't look right for a movie enthusiast to do that for 24p content.
Okay, frame rate handshakes are synced. Isn't it before the image reproduction with the EDID? Why do we need VRR?
But it's not going to vary. This is talking about it can be 15 frames per second for 1 second, 100, or not, actually it's going to high, but 15 frames per second for at one scene, and 120 frames per second at another scene, and 33 frames per second at this scene, and 67 frames per second at this scene. And it is changing every second. Displays don't do that right now. And it's for gaming. You don't need this for video. Video is done in 24p. It's only the game system that is rendering each file individually based on what you're doing on the game. So that's why this exists. All right. All right. So let's move on. Some more questions. We'll get some more questions later. I want to go through some of these other texts. So the first thing was variable refresh rate, changing the frames and based on what the computer can build at that time, and that's done by the second to optimize gaming. The next one is gamers want the quicker the system responses, the quicker that your TV responds and shows you the next frame, the more of an advantage you have over your competitor. So I come around the corner, you come around the corner. If I see you come around the corner first and we're playing some sort of a shooting game, I am going to win. If I see the ball move in a soccer game before you do, I can react to the ball faster and I'll probably beat you to the ball, and I'm going to be a better soccer player or football player in a video game. So the frames have to get there right now. So what quick frame transport does is it ensures that the frames get from the display device through the HDMI to the display and to your eyes faster. The way it works right now is even if say the computer built the frame faster or the video game built the frame faster, it has to wait for the next slot in the HDMI chain before it can send that content to the TV. So say it finished frame one and it's ready for frame two, frame one is still going down the pipeline, it has to wait. So what quick frame transport does is the second the frame is ready, it sends it down the HDMI line. How the science works is hard to explain, but basically it allows your display to get it quicker and react faster. So a lot of times you will get the jump on the competition. And anytime I get a jump on the competition in video gaming, they want it. People spend 6 times more for a faster graphic card to get more frames per second, and this ensures that you get those frames as quickly as possible. Okay, but the display, the repeater, which would be like your receiver, and the source, the game system graphics card has to support this. Moving on. The next thing, auto low latency mode. All of our device, there's a lot of times when you add video processing, upscaling, color correction, all those types of things, it takes all of that processing delays the signal. So say I send that signal to a TV and the source was directly connected to the sink, which is the TV, and the TV's gonna upscale it and add more color and do all this different stuff. While it's doing all that processing, it is not showing you the picture. And that is basically lag, the difference between when I send you the signal and when you see the signal. So TVs, as well as receivers, like our Denon and Marantz receivers, have a game mode built in. But currently, I have to manually turn both of those on. So auto low latency mode, what happens is if I'm using my PlayStation for watching streaming content, all of the video enhancements are on in the receiver, which is the repeater, and in the sync, which is the display. The second I stop watching streaming content and I switch to a video game, the game system will tell the receiver, I'm playing a game now, and the receiver will automatically switch into game mode and tell the TV to also switch into game mode. So what happens is when I'm playing games, I get optimized gaming performance, no lag. And when I'm watching video, I get optimized video performance with video enhancements, great gaming, and great video automatically. By the way, this is actually built, game mode is actually built into our receivers as right now. So if I go into this is actually, I was going to show you using the on-screen menu on my TV, but it's easier to do it this way. So if I go into the video settings this is my, oh, by the way, Denon and Marantz receivers, the newer ones that are network capable, have a web UI. So instead of using the on-screen menu, if I and my remote on, if I know the IP address, which is easily can be found out by looking at the receiver's menu, I can log on to the same network as the receiver, type in the IP address, and go directly to the menu. All right. So if I go here to output settings, you'll see here it says video mode. Right now it's set to auto. So it's trying to predict. I can manually force it into game. And what happens is with auto low latency mode, it will always switch into game. And it'll do things like turn off IP scaling, turn off video conversion to speed up the process. So instead of auto sometimes works, auto low latency, it will always work. Actually, this auto low latency right now is waiting for auto low latency. So right now, if this game system has this and the TV can support this, the receiver defaults to it already and it will work automatically. Okay, any questions about that, Jim? I know most people have never even seen that before.
Yeah, there was a quick one. The web UI, only IP address or port also?
IP address. So you go in, you see the 192.168.1. Whatever that number is going to be, 183 or whatever. You type that in, and it will come up. And so a lot of times, if you want to do things like change your, I go in and I change all of my inputs. So instead of being HDMI number 1, it's Apple TV, and it's a lot quicker to make those changes from that application. But it's easy for me to show it here than the remote. And a lot of people don't even know it exists. So I just kind of thought I'd throw that in there. Okay, so when we talk
that
about
was good. Now we got to go back and figure out which Denons have it. I think it started with the 3500 series, but I don't.
Yes, I believe 3500. So
That's what I
FY19. So 35. We added networking in 2000.
No, 18.
2018. 2018 support everything above that.
Does the ALLM option have a direct RS-232 code for direct turn on using automation control systems?
But in auto low latency mode, you don't have to do anything. Nothing in your control system. It will do it automatically. Don't touch it. The game system will tell it to switch, and the receiver and the TV will switch. No commands required. That's why it's called auto low latency mode. You don't have to do anything. And if you look here, that is available on starting with Denon and Marantz pieces from 2014. The AV8802A, which was the pre-pro, the high-end pre-pro back then. And you can see, so that's been available on a variety of Denon and Marantz AVRs. We were just waiting for everybody else, the source device and the TV, to be ready for it. So that's an example of us being ahead of the game, like we always are. Now, there's also game features that enhance video and movies. And because those ones we talked about are mostly gaming stuff, the two that stand out the most, actually there's three that stand out. The first one is enhanced audio return channel and quick media switching. So let's go talk about these real quick. Audio EARC, or audio return channel. So ARC stands for audio return channel. I send video from my that was sources connected to my receiver. The video goes through the receiver to the TV through the HDMI. Then the TV can take sources internal that are connected to the TV directly or built internally into the TV and send that sound back down that same HDMI line. So the difference between ARC and EARC is you do have to use a better cable. So you want to buy an HDMI cable with Ethernet, which is most of the better cables. Check for that. And what you end up with is Dolby Atmos and DTSX, but it is uncompressed. You get the best that Dolby can offer you, which is Dolby True HD and DTS Master Audio. This all depends on if the source that is connected to the TV or the streaming service that is built into the TV is sending out uncompressed audio. So if Netflix or Disney Plus or one of these services, Amazon or YouTube, whatever, decide the sound is encoded in uncompressed audio, it will send that uncompressed audio down the pipeline. Not every source is, and not every service, streaming service, is outputting uncompressed. But this just ensures that when you have eARC, you're going to get the maximum that that service can provide. And what you'll notice is you'll see on the receiver which input is you should go. Normally it's the monitor 1, and you'll see on the 1600 it says ARC/eARC. And on the TV, you'll see that you have to plug that HDMI from the TV to the receiver. The TV input has to be HDMI number 3. You plug it in the 2, you plug it in the 4, you plug it in the 1. ARC is not going to work. You also have to turn this feature on in the receiver and on the display device in order for them both to accept it. And finally, if you look at some of our older models, such as this has been available since 2017. I have a AV8805 Pre-Pro, and which if you look here, everything above the 3400 and above, and everything above the Marantz 1612 and above has had ER capabilities. We were just, since 2017, we were just waiting for everybody else. So my AV8805 has it, but the monitor output is just labeled as ARC, even though it supports eARC. All right. The newer receivers that we launched in 2019, we decided to put the label on there. But no, I mean, in 2019, we decided to put the label on there. But everything from 2017, pretty much everything, all of the better models from 2017, all the better models from 2018, and pretty much everything in 2019 supports eARC. Think of it as 4K streaming services or Netflix, where it's compressed 4K versus 4K resolution from a Blu-ray. That's what the difference is. Okay, so that's actually a good question, because probably other people had a question about that too. That's another reason why you never use optical, people. That's the reason why you never use optical. Optical will not do anything on most receivers besides stereo. If you take a optical cable and connect it from your TV to your receiver, you'll probably just get stereo or Dolby Pro Logic. There are some TVs, like some Sony TVs, on certain apps, if you set it up the right way, that will give you 5.1. But if you want Dolby Atmos, DTSX, 5.1, 7.1, you have to use ARC. If you want all of that stuff uncompressed, that's where eARC comes in. When you watch video, you will see that there is a blank or a blink between when you switch from one source to another, especially on a projector. And that is because you're switching from one frame rate, maybe 24, to another, the menu, which is 60. Or you're going from a 30p TV show to a 24p movie. You will end up with a blank picture. Apple TV, we talked about that yesterday. You have to go in and make adjustments to it to maximize its performance, because what they do is an Apple TV takes everything you watch. Actually, a Roku does it as well, and if you leave it in its default, will show it to you at 60 frames per second. And so an Apple TV takes all of your 24p HD material, 24p HD SDR material, and the Apple TV will automatically try to upconvert that to 4K 60p HDR, just to eliminate the blanking. If I go in and I set the Apple TV to match format and match frame rate, I get a better picture, because the Apple TV is not trying to convert stuff it should not, but the picture will blank. The goal of quick media switching is to eliminate that blanking. So so whenever you switch from one source to another, from one frame rate to another, it's instantaneous, and you don't have that blank screen. On a projector like my VW 695, a lot of times that blank could be 3 seconds, and it seems like eternity. It's not, but it just seems like it. And it's annoying, and this will help eliminate that. Okay. Um, one more thing, and then we'll take some more questions. The next thing, another part of the standard is dynamic metadata for HDR. So what is this? Well, when you metadata, when you go from watching standard dynamic range to high dynamic range, the display device has to tell the TV to adjust all of its parameters because the signal is different. It's like we were speaking Italian and now we're speaking French. So the TV and knows what language, how do this, what color triangle am I using? What brightness range am I using? So we can adapt. That is the first thing that goes down the line for HDR. It's called dynamic. That is called an info frame. The next thing the TV wants to know is, well, what do I have to prepare for? So static metadata looks at the brightest pixel in the entire movie, and that becomes a number, 4,000 nits. And it looks at the frame, the one frame in the movie that had the brightest average brightness. And then that becomes the other thing they send out. So it tells the TV it's going to be HDR. Here is the brightest pixel in the movie, and here is the number of the brightness of the brightest frame in the movie. And the TV will take that information and try to adapt itself for that, because most TVs cannot display the maximum resolution, maximum brightness, the maximum color space of an HDR signal. So it has to do what's called tone map to get the most from that signal. Now that works. So say this is actually out of the movie Blade Runner, the remake of Blade Runner. So this picture with Harrison Ford is the brightest frame, and it has an average brightness of 400 nits. And there's a snowflake way off in the distance over here, and that is the brightest pixel in this movie, 4,000. So the TV adapts for that. But this other scene is in the movie as well. And the TV is adapting itself solely for this super bright frame. So when I show a darker frame, it doesn't change its parameters. And so that darker frame is not optimized. With dynamic metadata, frame by frame, the TV is provided the information about the brightest pixel in that frame and the average brightness of that frame. So the TV can automatically and quickly adapt. So every frame of the HDR content is optimized based on the TV's capabilities. That is called dynamic metadata. That exists already. It is called HDR 10 Plus, which is Samsung's kind of proprietary technology, and the one that most companies have adopted, which is called Dolby Vision. Both of those are proprietary. Dynamic metadata now is just another standard that is an option that is non-proprietary. It's a universal format. All right, Jim, any questions there?
Millions. So
notice if it's so funny, we are always go over because the questions are rising, but that's just okay. We're going to go probably a half an hour over. I apologize. So those who have to drop off, please come back and scroll to where you stopped, and you can watch the rest. Okay, go ahead.
Thank you for the showing the ALLM. It was great info. Let's see, where do I have to? Sorry, I'm going back up. All righty. So on an Apple TV, can you adjust the frame rate, and where should I set the 24 frames when watching movie? On the source or on the TV?
Okay, when it comes to an Apple TV, go into the Apple TV, go into the settings menu, and you will see two options: match frame rate, match format. Turn that on. It is defaulted to off. And when there's a 24p movie, you're watching it on Apple, Netflix, or whatever you're watching, it will send 24 to the TV. It will not mess with it. If the content is HDR, if the content is SDR and HD, it will send that directly to the TV. It will not mess with it. That is match format. If it's match frame rate, if it's 24p, it will send 24p. It won't mess with it. If it's 30p, it'll send 30p. If it's a 60p piece of content, which is pretty rare, it'll send 60p, and it will not mess with it. So that's all you have to do: match frame rate and match format. You'll make the file sizes smaller that you send that through your HDMI cable, so you have less problems, and you will get a better picture. So that's all you have to do.
Take a stab at what is the frame rate for TV serials? Do you have any idea?
It depends on the country you live in. In the U.S., it's 29.9 frames per second, 30 frames per second. In many other countries, it's 25. I believe, right? I would have to go to Frederick on that, but most of our stuff is 30 frames per second. And then you guys maybe what, 25 or 50, depending
Yes,
on
that's exactly. You're correct.
exactly.
It's
So
PAL versus NTSC. Yep.
exactly. Now here's an interesting thing about that, by the way. In the US, we use both 29 frames per second, and we use 60 frames per second. Certain TV stations that do a lot of sports broadcast at a resolution of 720p at 60 frames per second. A lot of stations that do a lot of movie content transmit at 1080p full HD at 30 frames per second. If you take the file size of a 1080p at 30 frames per second, it's the same size as a 720p at 60 frames per second. So the studio just picks the one based on content. Sports is going to look better at 720p at 60, which is probably what they're doing for you. They're probably doing 720p at 50 for your sports, and 1080p at 25 for your movies. So that's probably what they're doing, because that's pretty much how it relates to the United States.
Are all the movies on Blu-ray 24 frames, recorded with 24 frames? If yes, and the display is being used only for movies, would you set the display to 24 hertz or auto?
If you look at most TVs, they have a cinema mode as one of their picture quality options. If you select the cinema mode, most of these TVs will default to turning off 3:2 pull down and starting to just repeat the frames and using backlight blinking to make it look more cinematic. So you just go into the TV and look at, like, a Sony TV has cinema. So you would go into cinema mode and you would just turn that on, and normally that's all you have to do, and all those other settings in the TV will be done for you. You can go into the TV and go into, like, cinema. There's always some sort of cinema, or turn off 3:2 pull down. There's a lot of other settings in the TV, but most of the time for a Samsung, a Sony, or an LG, if you set it to its movie mode or its cinema mode, it will automatically just try to play 24p at 24p.
Well, this is an interesting one. If you're watching a movie on a PS5 or a PS4, would it change the mode to game mode? Or is it the game itself that flags for ALLM?
If you're watching, it is the game system that flags. The game system is smart enough to know if it is playing a game or if it is playing video. So second it sees it's playing a game, it just sends out the information, I am playing a game. So Xbox does that. It says, oh, game, and it just automatically does it. Remember, these things are smarter than most desktop computers. The biggest issue that we're going to have is, we just talked about all of these great services. We talked about variable refresh rate, quick media switching, quick frame transport, auto latency mode, eARC, all these different things, along with 8K and 4K. Those are all parts of the HDMI 2.1 standard. But the problem with HDMI 2.1, the new standard, is a TV or a display or a source does not have to be able to do all of them. Samsung doesn't support, they support most of them, but they don't support eARC. Sony supports eARC, but they don't support some of the other ones. So the only way that you know what the TV is going to support, and by that's the amount of things that are supported even in a brand will vary from series to series to series. So it can be really confusing. So there are test equipment machines. So for example, this is the newest one that just came out. This sucker costs about This one's $5,000. It's slow. So,
Yes.
so what I can do is I can actually measure all of those different things. I can test eARC and sync and how much cable is going down the line and what features are available. And all that information, if I plug a TV into this thing, will appear in this little gray spot down here. So I don't think most of you are going to have $5,000 for something like this. So how do you know if a TV can what features are available on the display that you're using? The receiver itself will tell you what features are available. So not only will it tell you what type of HDR you're running, what type of resolution you're running, it will also tell you whether it's variable refresh rate and whether the features are supported. So I can say, wow, okay, what I'm watching is eARC, which means uncompressed audio with quick media switching, and I can see all of that stuff based on the TV, on the AVR's on-screen information menu. So instead of you having to go out and buy a $5,000 testing thing, the receiver, if I hit the info button, will tell you what is going on the monitor out, which is where most of the major devices are located. So that's kind of nice. So a couple more things, and we'll go through and then we'll answer questions at the end. People keep asking, what about my current AVRs? Well, we already talked about the fact there's no video content. There's no announced physical media. You can't put 8K content at 48 gigabits per second, 4K 120 or 8K 60 on physical media. Movies aren't shot in it, okay? TV stations aren't going to give it to you at that resolution because they don't want to give up 16 channels to give you one 8K channel. There's no streaming boxes really available right now. The only thing that's going to support it is going to be the game systems we talked about, and maybe a TV's internal applications. And if you have one game system, or you're using the internal streaming services, remember our receivers support ARC, eARC, and auto low latency mode. So I could take one of these fancy gaming systems, and what I can do is I can plug that gaming system directly into the TV because I want the game system close to the TV anyway, so I can change this and things like that, and it will send out the information, the audio from the game to the receiver via eARC. And so that's pretty cool. Another part of eARC we don't talk about is it also has a really good auto lip sync as part of the feature as well. So you can actually utilize that to maximize your performance. So great gaming this way. My phone's ringing, I apologize. Now, the other way you can do it is whether I have a new receiver or an old receiver. We talked about the fact that most of these services are going to be internal, maybe 8K streaming from YouTube or 8K streaming from Netflix. Well, that's built into the TV. And then you can feed that signal back via eARC, so you get the maximum sound quality that particular service and that TV is capable of utilizing. So you could use your older receivers, your 2.0B receivers, or your 2.1 receivers. The only time where you may start thinking about really start being concerned is if I have multiple 8K sources, or I want to plug that source directly into the AVR. But at this time, most of the time, you're not going to be plugging. The game system is going to be closer to the TV. In my home, my game system's in the rack, and so yes, I want switching because the game system's in my rack, and I would want to send it to my TV over here. But right now I have a 4K TV. I don't care. Over here I have a 4K projector. I don't care. Neither one of these support 4K 120, so I'm not motivated. If I buy another $30,000 projector, another $8,000 TV, then I would probably consider upgrading my receiver for something better. You notice that is an AV8805, and there's a reason for that. If someone decides that they want HDMI 2.1, it can be updated. So if a person has to have it, and they're buying at this level, they're probably buying expensive projectors and expensive TVs, and we're going to offer an update package for these particular devices. Hopefully, way. Well, I can't tell you what, I can't tell you when, but it's coming. And you'll be able to buy this today. And then if the client decides they want that 2.1 up capability for the 48 gigabits per second, they can send it to a service department, depending on your country. That is a different service department. They'll your reps and distributors will tell you where to send it, and they will upgrade it. They will pull out the old HDMI board and put in a new HDMI board. In the meantime, ARC is important. So as I brought it up yesterday, be sure when you buy Balance, or as you guys call them, HDMI extenders, that they support eARC, because you're going to need that if you want to make sure that a person can utilize their 2018, 2019, 2020 Denon and Marantz receivers in this 2.1 world. We also mentioned that as cables get longer, bandwidth gets harder. So I would suggest you plan for that and use cables that are active, like we talked about yesterday, the active cables, like we talked about yesterday, which allow you to run longer bandwidth, longer distances, and still maintain bandwidth. Okay. So, and last but not least, bigger is not always better. There will be, there's also a compression scheme that is built into 2.1 that is part of most TVs, and most sources will have this, and our receivers will be able to pass it. And this allows them to actually use lossless compression to actually make send even higher frame rates. Using this type of compression, you can actually do 10K 120 using 48 gigabits per second. So hopefully using this type of compression, we won't be having this conversation anymore. We talked about this yesterday. Just because it's bigger, don't automatically select it. For example, 4K Blu-ray, I can do it at 30 frames per second with a color subsampling of 444 or 422 on most systems. That is basically how many times the colors are sampled, and those samples are provided to how many times each color information, how many times each color is, that information for each color is provided to display. So 444 means I tell the TV every time what the red, what the green, and what the blue is. 422 is I tell the TV what one color is all the time and the other two colors every other time. And the TV uses mathematics to figure it out. If you look at that, going from 444 to 422, if you reduce that, it cuts the bandwidth in half. So you go, well, why would I want to use 444? Because what lives on the Blu-ray disc is 420. So either the one thing, something's going to have to do the conversion from 420 to all the way up to 444. Would you rather let your display do it that you spent $5,000 on, or a $100 Roku? I think the display would do a better job. So send the minimum 422 down the line and let the display do it. People go into Apple TVs all the time, or their Blu-ray players, like their Opals. I have that big Opal behind me that allows me to turn everything up. I can turn up to 12-bit 444, and all I'm doing is taking something that was 10-bit 420 and artificially and bumping it up early. And I'm just making it harder for all of my HDMI cables, my receiver, my splitter to pass the signal. So do not go into things and crank everything up. If you're a gamer, if I go from 422 to 444, that is harder to render. So the game system will render less frames. And as a gamer, twice the frames is a bigger advantage than you telling the computer to send full information for all the colors. You will die. All you will see is your character laid there with the victor standing above you with his sword, but you'll see all of the colors in the best way possible. So a lot of times, even for gaming, cranking it up to 444 is not an advantage. Do not go into your receivers and your displays and crank it up, because all you're doing is making the file size bigger, because what's on the video is only 420. So send the lowest thing that your TV will accept, which is normally 422 on a Blu-ray player, on an Apple TV and on a Roku, to the display, and let the display do the rest of the work. Okay? Because if you look at this, 8-bit, the main thing you want is good color. 10-bit color is what you want. If you look at 8-bit color, there's only 16 million colors. If you look at 10-bit color, there's a billion colors. So if you look at 10-bit 422, it's a better picture, even though it's about 30% smaller. The next question I get is, what about 12-bit? Don't waste your time turning something up, your source devices up to 12-bit, because there is no display for consumer application, with the exception of maybe a few JVC projectors that are actual 12-bit displays. They are all 10-bit displays. All of your OLEDs, all of your LCDs, all of your DLP projectors, most of your regular LCD projectors use a 10-bit display system. So turning it up to 12 is a waste of data, because it will not support it. Now, there are some gaming monitors that are 12-bit monitors, and there are some professional displays that are 12-bit monitors, but anything that's normally used like a commercial TV from Samsung, LG, Sony, Vizio, Hisense, TCL, whatever you want to name, and 99% of the projectors are only 10-bit displays. So don't try to crank it up to 12. You're just wasting data. You're making the game system render less frames. You're making the file size bigger to run your movies from point A to point B, and you're going to get a zero benefit. Okay, so I want to get that across. And then last but not least, whenever you run HDMI, run a wire. All right, Jim, I'm done. Questions?
Okay. Sorry, Phil. Can you please explain EDID again?
EDID is the communication. So if you look at that big fancy box I was showing you, it could read all the information about what the device can do. I showed you that menu that said it supports eARC and VRR and VRM, and it's HD2. Basically, what it happens is the source device is a player. Then you have what's called a repeater, which is your receiver or switch, or a pair of HDMI extenders, and then you have your sync, which is your display. All of them, the source is going to ask them, who are you? Give me information about who you are. And the TV says, I am a Samsung 4K TV with this resolution. That is the EDIT that is provided through the repeaters back to the source device. So the EDIT is just an identification of what the device is, what the display device is, and what that display device's capabilities are. So the source device knows, oh, you can handle 4K HDR. I'm going to send it to you. Oh, you're only an HD TV. I'm only going to send you HD content. And you can see it with Netflix. If I plug an HD TV into my Apple TV, it just says, and I go to Netflix, the content will say HD. If I plug in a 4K TV, the Apple TV reads the EDIT from the TV and says, oh, you can handle 4K HDR, and then magically right next to all the shows, or a lot of the shows, are 4K HDR. So that's what EDIT is. Device ID, electronic device ID, is what you want to know what it stands for.
And there was a question about most of the content on Netflix and Prime has multi-channel audio and not Dolby Digital or DTS. Why isn't it being reproduced in the original soundtrack when they're sending the signal over?
Oh, well, when you buy a Blu-ray, even a regular Blu-ray disc has the 7.1, the 5.1, and then maybe a Dolby Digital, maybe a Dolby Atmos on that particular disc. It all depends on whether the service wants to grab it or not, and utilize the space. You're starting to see more Dolby Atmos available content on Netflix. It all depends on how the application is built. If I get some streaming services, it will pass 4K HDR with just 7.1 or 5.1 on certain streaming boxes. But then I go out and buy an Apple TV, and Apple TV said everything that you provide us has to be in Atmos if it's available in Atmos. So if I play the same movie on an Apple TV, 4K Apple TV, from Netflix, it will be in Atmos. So if you're trying to get as much Atmos as possible from streaming services, your best solution is probably an Apple TV, because in the US, Netflix, Disney Plus, select Amazon Prime movies are all available in Atmos, as well as other services such as Fandango. So it all depends on the streaming box and whether or not that app and the app that the streaming box uses can support Atmos or DTS:X, and whether or not the studio provided that file to the streaming service. Okay.
Can you explain how to hook up and connect ARC? Do you want to go in? Do you want to pull up your 8805 again and show them how to turn that TV audio on?
Okay. So the first thing you're going to have to do, hold on a second, let me take my computer back up, is it's been a while since I hunted for that thing. So ARC should be under HDMI settings, I believe. HDMI setup. And so what happens is I would go into my menu, either on screen using the remote like I'm doing here, or using my remote control. I would go into video settings, because it's a video setting for some reason. They call it video because we're talking about the HDMI cable. I would go into HDMI setup, and you see down here it says ARC. You would just basically turn that on. All right. The reason why I don't have it on right now is because for my main device, I'm not using any sources currently, most coming from my device right now. So I have it turned off. So I can turn that on. The one above it is called HDMI control. A lot of older TVs, you have to have its CEC. Sony calls it Bravia Sync on to have the ARC work. So what happens is you can tell the receiver, ignore the control portion of Bravia Sync, just grab the audio. So newer TVs allow this to be separate. If the TV does not allow you to separate it, you can actually tell the receiver to ignore it. And that is where that exists. Okay. Next question, Jim.
Hopefully that helped. Yeah, the TV setting part, you've got to do that. But
and you have to look
let's
at manufacturer. Each manufacturer is different. You got to look in the menu and look under ARC. They're going to tell you how to do it. Or look under Bravia, go to their sync or CEC control. Every company has a different name for it, and find the right one. So I can't really even tell you how to do it for each TV. Okay.
Yep. Another question about protecting for HDMI board damage. You want to talk about that again a little bit?
Yes,
and what you can and can't do?
Yeah, because what ends up happening is there's the video processing in a receiver and is very sensitive. That's very small little minute little parts. Big spikes in voltage to the AVR could cause damage. So of course you should have if you look at mine, I have a surge protecting power conditioner there to hopefully stabilize the voltage for my more sensitive devices that are in this rack, my computer as well as my receiver. Unfortunately, there is no surge protection box that you can protect the HDMI wire. So I would just say make sure that you have good surge protection on your TV and you have good surge protection on your electronics components, and that's probably the best way to protect it. Some other times that there's problems with video signals or problems with AVRs having problems with video boards burning out is inexpensive cable boxes have a habit of damaging the video processing boards. We had what company was, which board was that one? That was from a cable company. It was a Comcast box. There was a Comcast box that had voltage problems, and it would spike and it would damage video boards in AVRs. And most of the times we had problems with our AVR video boards, it was one of those Comcast boxes that was causing the problem. This company here, Metro Home Theater, they make HDMI solutions and boxes to try to solve some of the issues you will see in when it comes to HDMI. They also sell everything from install tools to diagnostic tools to all sorts of cool things that you can use to do everything from fiber and also boost the quality of copper HDMI. So this is actually a very good place to go if you're looking for little gadgets and tricks to try to solve issues. So I'm not sure how available they are in your particular regions, but it is a very good company for those types of tools and tricks. Go ahead.
Optical out from the TV to the AVR
Never do it.
versus HDMI arc out, and explain why you would never do it because of all the problems people have with ARC. And a related question is, do you think EARC will be less problematic than ARC?
Okay, so number one, optical out for 99% of TVs you will see the beautiful Atmos logo on your service or your 5.1, but what you're going to send your receiver is going to be stereo, except for maybe a few Sony devices. This is because the HDMI is plugged into the TV, but they peel off the optical signal after it's been converted for the TV speakers, which are stereo. So what you end up with is stereo sound going from your TV to your receiver. Never use optical to send information from a source from a TV to the receiver. The reason why you were having problems with ARC is because CEC and ARC used to be connected. We just showed you that the receiver, you can separate them. So separate them in the receiver, and if you can, separate CEC from ARC in the TV, and that will help you eliminate some of the problems. eARC does have some new enhancements to make the performance better. Each manufacturer is realizing, whether it's a receiver manufacturer and a TV manufacturer, that ARC has to work, and each company is working on making it better. Because as much as you don't want to use it, the customer wants surround sound from a source that's connected directly to the TV or built into the TV. That's your only option, like it or not.
Okay, would you talk a little bit about when you should use the upscaling feature in the AVR versus on the TV, particularly with projector-based setups, and maybe what to look for in the display where you know the upscaling on the display would be the better way to go?
Okay, first thing, like I was saying, turn on the display, turn on the receiver, pick a file that has a lot of detail in it. Trees, plants, buildings, human faces are not enough detail. It needs to be really, really fine detail. You may actually have to walk closer to the display than to really evaluate it than where you're sitting. Go into the receiver and switch its HDMI, its up conversion on, and look at the picture. Take note of things like bricks and cobblestone roads and everything else, and then switch it off and look at the image again. Pick the one that looks better. The other thing you can do is take something like a car driving down through the city and play that scene with it on and look at, is there any artifacts or tearing or weird things, and then play it with it off. And then if you look at it and say, wow, when there's motion, the objects in the background look better if I use the projector or the TV's upscaling. And when it's static, it looks better if I use the TVs or the displays upscaling. Pick that one. If you have a TV and all of a sudden you run your AV8805 and you go, wow, it actually looks better using the receiver's upscaling, pick that one. All right. That's the best way to do it. If you're having problems with your HDMI cables and the signal is blinking out when you use the projector, the receiver's upscaling, that tells you your HDMI cable can't handle 4K. So let the display do it, because it's going to help your reliability when it comes to your HDMI cables and switching. So that's how I would say do it.
Phil,
Yes.
there is more than a screen of questions, and we still have 140 people here.
Okay. Well, what we're going to have to do is anything dealing with 12-bit or cables. We have a please refer to the session 1 and look at the presentation from session 1. A lot of those questions will probably be repeats from yesterday.
Please tell them where they can go see it. Can you put up the YouTube channel?
Yes. Thank you, Jim, for reminding me.
That was from Jen.
So if you really want to dive into this stuff, I guarantee you that if you go to, wait, it's a little slow today. Please subscribe to our YouTube channel. We have talked in detail about HDMI 2.1, HDMI bandwidth, long cables. See the gentleman down in the red with the beard on? He is actually from Metra, and he talks about challenges with HDMI and everything else. So anything you will ever want to know about HDMI or wireless music or high-res files are available here. We're going to start adding stuff about speaker setup, and everything else will be available here, because it's a lot. We could spend forever just answering questions, but a lot of these questions will be available here, and eventually we just run out of time.
But this is a good one. I think this is a good one, and we still have 120 people.
Okay.
Should they play the smart content on a smart TV, an Apple TV, or some other, device like a Roku or whatever? Which is the better way to handle it with bandwidth optimization, et cetera?
If you're concerned with bandwidth, the best way to use the TV's internal, because if I use the TV's internal, any HDMI cable with Ethernet will send the surround sound back to the receiver via ARC, basic ARC, and I get the best quality video and I get surround sound. If I use a Roku or an Apple TV in here, now I got to send that high quality video from this rack 20 meters, and that is harder for the cable to do. So I have very good cables. If the customer has very good cables, you've had no problems with your cables, and you're running a control system, a lot of times people prefer an external box. But if you're having problems with your passing video of the highest quality from the rack to the TV, a solution may be use the TV's internal streaming service and send it back to the rack.
The other thing I'm gonna weigh in from my personal perspective.
Mm-hmm.
You have to make a decision on the user interface as well. I personally don't like the user interface on many smart TVs, but I do like I'm a big proponent of Roku. I love the user interface on Roku. But that's me.
I
like
never
Apple TV, right?
Yeah, I have both, and it's funny, I bounce back and forth between both, so I can't tell. I just wanted options. So I don't use my smart TV's applications very often, but it's nice to know that they're there. Because for example, the IMAX Enhanced service through Sony is only available through the Sony TV. So if I want to watch streaming IMAX Enhanced, because they just announced they're going to launch 100 movies over the next year or so, most of that stuff is going to go up on their service. So I know that if I had to pick, that's probably going to be where I have to get it from, unless I go to Fandango now or something like that. All right, so we got to let you guys go. So thank you again for coming to my home and spending time with me. I greatly appreciate it. It's always a pleasure to know that you guys find this information helpful. And I'd like to thank Jen, Jim, and Frederick for doing this. I know I'm dealing with all these questions. It's like herding cats, trying to get a bunch of cats to go in the same direction. And I really appreciate them doing all of this work and taking the time to assist me. So I would like to say thank you again, and hopefully, I'm sure Frederick had some more ideas for some more sessions based on what we just went through, and we will make sure that we get together and talk again. So, all right. So thank you very much for your time. Yes.
Thanks, Phil. Great job, as
Okay.
always.
Yeah. So thank you so much for your time, and I will talk to you soon.
Thank you, Phil.
Thanks, Phil. Much appreciated. And for those, see you tomorrow.
Bye-bye.